Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, this is a revision video and on lesson 2 Pythagoras theorem of Maths 2, and the purpose is to go through the topic again as well as to give you important questions. For that purpose you should go to the description, and I have given the link of my previous 2 videos over there that you will watch thoroughly, where I have explained the theorems mainly with the help of textual examples, which is the foundation for every topic. The theorem part and its examples are, as I always say, said, it is examples will be selected ones, which will be one example will help you to solve at least 5 sums in that topic. So that way my videos, 2 videos, so we will go through it once again with a lot of patience, and you will come back here and will go ahead, because some questions are given which are appeared in the previous year's question paper. Thereby they are important and they are simple questions. I don't think that always there will be tough questions. At least 40% of the questions will be easier one. So please go to the video, come back and continue the video. Okay. So without wasting time, let me get into the solution of this. Find the height of an equilateral triangle whose side is 6 unit. The concept by reading this we understand as it is given equilateral triangle, and chapter I told second 30 60 90 degree theorem or 45 45 90 degree theorem. You should be familiar with this. This concept should be very clear, because very frequently this kind of very simple questions are asked in the exam. This has come in the years 2016 and 17 in the question paper. 2 times this question has appeared. Similar, very simple 1 mark question it is. So the question is simple, and find the height of an equilateral triangle whose side is 6 cm. The solution can be easily obtained. Not a tough question, in fact very simple 1 mark question. It is given that side of this equilateral triangle is equal to 6 unit. And we know that if side is given, the height can be calculated simply by applying the formula, which is nothing but, let me root 3 upon 2a. So you will substitute a and get the answer, which is 3 root 3. As the unit is given as unit, you will simply write that. It is that simple. We will go to another sum. One mark question, easy question. Familiarity of this concept is very important. Let me go to another question from the previous year question paper. In PQR, point S is the midpoint of side QR. If PQ is equal to 11, PR is equal to 17, PS is equal to 13, find QR. Midpoint of one of the side is given, right? You know about when midpoint of one of the side is given, something comes in our mind, and some sides are also given, sorry. Midpoint is given and sides are given, so we need to think in triangle. The concept it's related to what we say right angled triangle as well as Pythagoras theorem, Pythagoras properties, all these come in this chapter. So all this will be must come into your mind when this kind of question comes, and when we really do it, that concept bringing into the mind will help you. Okay, let us think about how actually the sum is. In triangle PQR, point S is midpoint of side QR. So you better make a simple a rough diagram with respect to the question. Okay, and it is also given that where is the midpoint? S is the midpoint. Okay, mark it as S. And it is also given that PR is equal to 11, no units, PR is equal to 17, PQ is equal to 11, and it is also said that PS is 13. Okay, now it is simple. These two are equal because S is midpoint, and that midpoint word is what is giving us all clue related to this, correct? So we understand that in that case QS is equal to SR is equal to half of QR, we can simply write, because S is midpoint, half of QR it is, which is very important in this context. And we also know that we are having the Polonius theorem, which helps us to do all these things. PQ square plus PR square is equal to 2PS square and plus 2QS square. So that theorem, when we apply, you get the answer simply by substituting the values 11 square, then we are having 17 square, then we are having 13 square. Only QS is not given, so damn sure that we will get the answer. Is it not? We are 100% sure. 121, 17 square is 100 and 289, 13 square is 169. Only QS square is not known. We will rearrange it, recopy it and go further. 1 second. This much you understood, I think, and I will be moving to a new page or a screen, so that you should keep the last line in mind, and we'll go ahead. 121 plus 289 is equal to, okay, we'll do further simply arithmetic. 121, 289 and minus 169, which is equal to 2QS square. And that means QS square is somewhat around 72. That means QS square 6 square, correct, 6 it is. QS is 6, and from the first equation QS, S is a midpoint, QR is double of it, which is asked, which is equal to 12 units, we can say. Okay, that was not that tough again, but when reading the question we will not get the idea. While doing the sum we will get the answer. That is the beauty of it. Okay, we'll go to another sum. In a right-angled triangle, if sum of the squares of the sides making right angle is 169, then what is the length of the hypotenuse? Very simple question, a 7th standard question regarding right angle. So you simply do it. Hypotenuse is equal to 169 in this case, because sum of the squares of the sides making right angle is 169. So simply supply Pythagoras and Apollonius theorem and I'll simply do it. Simply I will solve it here. We can straight away write hypotenuse is equal to 169. Hypotenuse square according to Pythagoras. Right? Simple straight question. Because it's a right angle triangle, some of the sides are given. So as it is a right angled triangle, we can simply write Pythagoras and solve the problem. Okay, so 169 is nothing but hypotenuse square. That is the meaning of sum of the squares of the sides are given. That is the Pythagoras theorem. Right? That means root of 169 is equal to the length of hypotenuse. Okay, it was a straight question, simple question. Let me go ahead. In triangle MNP, angle MNP is 90 degrees, segment NQ is perpendicular to segment MP. MQ is equal to 9 and QP is equal to 4. Find NQ. So let me draw a triangle as a right angle triangle, because MNP 90 it indicates that it is a right angle triangle. Right angle at N. So M will be here and the right angle and P here, and I will write 90 degree here, and it is given that NQ, which is perpendicular to NP, that is also perpendicular, and it is meeting at Q, and MQ is given as 9. Okay, MQ is 9. Very good. QP is equal to 4. Find NQ. Okay. So we will put this data in the given given triangle. It's equal to 9 and here it is 4, and what is asked is NQ, and this is just like we have taken the right angle triangle and drawn a perpendicular to the hypotenuse. So the concept is very simple. The properties of right angle triangle as well as it's coming into use. There are a lot of properties that you have studied as well as Pythagoras. Any of this will be coming in use here now immediately. And as it is a perpendicular drawn from the right angle to the hypotenuse, so it became we can simply substitute NQ square is equal to in fact MQ into QP, the theorem of a geometric mean. In fact, this theorem we have studied and that we are applying here, and QP is given. So MQ is 9, QP is 4, and NQ square is equal to 36, and NQ is equal to simply root of 36. So sometime it will be as simple like this, or applying straight away. Coming to another sum in the following figure. This is also a question asked many times. In triangle ABC, again angle B is 90 and A is 30. C is 18 centimeter. It is given in centimeter. Remember that unit is given, and you are asked to find out BC. So 30, 60, 90 is given. So the theorem of 30, 60, 90 will be coming in use straight away, and the side opposite to 30 degree is asked. So you can directly apply that theorem. 30 degree opposite to 30 degree, what will be the what is called according to 30, 60, 90 degree theorem. So we'll substitute the value here. The question is what is BC. we have to mention triangle ABC is a 30, 60, 90 degree triangle, correct? So we can straight that, and straight away you can write, after writing that you can write BC is equal to how it is connected with hypotenuse. BC is equal to the side opposite of 30 degree. So naturally we will be applying the theorem of 30, 60, 90 degree, where side opposite to the 30 degree, which is BC in this case, is half of hypotenuse, that is half of 18, that is, which is equal to 9. Alright, so we can solve this sum, and these are simple sums but repeatedly asked sums. That's why we are scoring mark in maths, correct? Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.